Morning, everyone. This presentation is about a ground assisted drone or UAV situation awareness framework for mountain hiking safety monitoring. The main idea is that a drone should not only detect hikers but should also help interpret risk and support ground operator in deciding what to do next. Mountain hiking safety monitoring is difficult because terrain can block visibility, weather can change quickly, and ground teams may not know the exact location or condition of hikers. Many UFV studies focus mainly on detection accuracy. This paper focuses on what happens after detection, how detection result can be interpreted as situational awareness and turned into meaningful monitoring output. The aim of the study is to develop lightweight ground assisted UFV framework for hiking safety monitoring. The validated part is an RGB-based pipeline using YOLO version 8M human detection and rule-based risk interpretation. The paper also proposed a future extension using a local LLM for contextual explanations, memory, prioritizations, and human-in-the-loop support. An important point is that the paper clearly separates what is already validated from what is still processes. This is the validated RGB-based architecture. It has three layers. In the sensing layer, RGB aerial images or video are captured and prepared. In the understanding layer, YOLO VAM detects human targets and summarizes the scene. In the active layer, the system translates those interpreted observations into safety states and monitoring output. The design is intentionally lightweight so it can run on modest hardware. This slide explains how the framework moved from detection to risk interpretations. Detection evidence include person count, confidence, bounding box scale, and scene context. The framework then apply a simple score, R equal alpha times 1 minus confidence plus beta times a normalized distance or scale proxy. That score is mapped into low, medium, or high monitoring states. The purpose is not to replace human judgment, but to give the operator simple safety interpretation. This slide presents the proposed agentic AI extension. It adds event and context memory, an agentic reasoning module, LM Studio as a local LLM runtime, and decision support output. It can summarize evidence, explain alert, and support prioritization. However, an important boundary must be respected. This extension is proposed future work. The experimentally validated part of the paper is still the RGB detection and risk interpretation pipeline. Now let us interpret the result without making it too technical. Instead of reading five numbers one by one, I will explain what they mean for mountain safety monitoring. First, can the system detect correctly? The precision is zero point 0.8. It's simple word when the system say this is a person. About 80% of those detections are correct. This matter because we do not know that we do not want rocks, trees, or shadows. to create too many false alarms. Second, can the system avoid missing hikers? The recall is 0.755. This means the model finds about 75.5% of the actual people in the test data. In safety context, this is very important because missing a hiker can be more serious than checking a false alert. Third, can the system run fast enough? The speed is about 13 frames per second. This means the system can process visual input fast enough to support practical monitoring, not just offline laboratory analysis. The MAP values give additional information about localization quality. The MAP at zero point 0.5 is 0.806, which means the model can locate people reasonable well. The stricter MAP from 0.5 to 0.95 is 0.420, which shows that very precise bounding box are still difficult. This is expected because in aerial mountain images, people can be small, far away, and partly covered by vegetation or terrain. So the overall message is balanced. The model is useful for practical monitoring, but human review and fuller field testing are still needed. This slide shows the operator-oriented dashboard concept. It is not claimed as a field-validated interface, but it shows how detected person active zones, risk level, and recommended follow-up action may be presented to operator and SAR coordinators. This is important because detection becomes truly useful when it is presented in a form that supports decision making. This slide makes the study boundary explicit. What is validated in this paper is the RGB aerial imagery pipeline, YOLO V8M human detection, scene interpretation, rule-based risk scoring, and the reported performance metrics. What comes next is the proposed agentic local LLM support with context memory, explanation, prioritization, and human-in-the-loop response support. This clear separation strengthens the credibility of the paper. To conclude, a drone should do more than simply detect hikers. It should help a ground teams understand risks and act more effectively. This paper validates a lightweight UFV monitoring pipeline using YOLO V8M and rule-based risk scoring. It also shows practical near real-time performance and an operator-oriented monitoring concept. Finally, it points toward a future agentic local LLM extension for explanation and response support. Thank you.